Again, we're talking MVC, the Model View Controller. And so here's a little diagram that kind of illustrates it, and then we'll watch the video in a minute. So the view is basically the interaction, like I was just saying, the thing that the user would see on the screen. The model is going to be the data. We'll use it as a term to describe it. You know, your programming is stored inside something. It needs to be and rely on something. And then the controller is the in-between that tells the communication of how this stuff is controlled on the interface. And the reason why they do that is just because it keeps it organized, is the way that they kind of put it.
So Jeff, is the view what we used to call the UI?
Yeah, that is the UI. Yep. So anything that you have on the screen, a button, input text, or anything, is in the view. That's why it's called a view controller, right? Remember, the view controller is the name of the box that we put things on, the storyboard, right? And then the controller would be the basic programming when we drag the action. Remember, we did an action, I think, to go from one screen to the other. And then the data would be stored in here, kind of like what we're going to do today when we start making functions, structs, and classes is what we're going to program today. We're going to learn about those three main concepts of programming. And well, it could be data as well and things like that. So as the user touches something, the controller says, hey, what are you doing? Oh, you want to do this? It goes to here, gets the data, then goes back to the controller and says, hey, you need to update this, and then it updates the screen. Okay, so let's watch a little video. Hopefully that'll explain it a little more to you than me just randomly. You know, you can read that book. It's a pretty long book. If you want to read more about that, that's where they start talking about MVC in the book on page 472. I know it's a little bit later in the book and as we go forward, but I wanted to talk briefly today just to get you the idea and the concept of why things are split up the way that they are in the program. Main discussion today, though, will be about, oops, you clicked on the wrong thing. Hold on. There we go. The main discussion today will be about the UI kit. We're going to kind of go through some of the pieces today. Again, we're going to start with functions, structs, and classes, and why you use one over the other. And we'll do some examples, and then you can continue. Basically, this is most of your applications are going to be a combination of these three kind of concepts together. Okay, and so you'll be working on some structs or classes that have functions inside them, and so on. So let's get to the book. I didn't bring my iPad. I was going to bring my iPad so we could actually read it a little bit easier, but I might have to zoom in as we're going along here. Because that is not very readable. What was the command to zoom in? Command plus? No. Was it command shift plus? No. Remember, I can't remember. Hold on. I think it was under accessibility, right? And then we were going zoom. What is this? Zoom in is equal, right? This command option equal. There we go. Okay. Let me get back to the beginning here where I want to start. Okay, so again, this week I'm going to start with Chapter 2, the units Introduction to UI Kit. Of course, UI stands for User Interface, and the things that we're building. So most of the programming is going to be structured in, and I'm going to kind of blow off strings for a moment and have you do that yourself. You kind of got an idea of what a string is already, right? Where it's text, You can give a variable a name with a string. We'll briefly go over it, but mostly what I'll talk about today, again, will be the functions, the structures, and the classes, and how these three are pretty much the foundation of all your programs. And we'll also open up some, I don't know if I can find them, some more advanced programs and just look at how they're organized so you can see it as well. There's some good ones from this book, and you can see where the structs are used, the functions are used, and all that. And so I still need to download that though. So again, mostly chapter 2 here. You might have gone over it already, so it's okay. We'll just review then for you. In this case, the first lesson in this chapter goes over lesson 2.1. Basically strings. String is where you store data. Mostly strings are characters or text. Text is everywhere. You'll find it on billboards, on social media, on bills, on cereal boxes. Should come as no surprise. Text is just a vital in programming. It is everywhere else. In this lesson, you'll learn how to use string type. You'll learn a variety of string methods that allow you to compare two strings. And so, again, I'm not going to type this in. I'm just going to talk about it right now, just so we can go through it kind of quickly. You should go through this chapter and try these. They're very they're kind of simple, but they have some good concepts. Again, we already know that the let is a constant and a var is a variable. You can just see the example right there. This one is if you want to empty a string, you can put an empty string with the double quote marks, 3 double quote marks. So if your string little needs multiple lines, simply surround. So that's multiple lines. That's 3. So as you can see here, they have 2 lines of text. That was it. What was the empty one? There is an empty one somewhere. It'll come along. Then they talk about how to bring together certain lines of text. And they talk about where that R comes from. Is a carriage return. You might have seen it at the end of your code when you were typing it in. Did you see that? Especially in the first chapter. There was a little R. And the carriage return turns the beginning of the line. Not sure. Oh, here's the empty one. To initialize an empty string, so it doesn't have any text in it. Of course, since it's a variable, then I can change it and put something in it, right? That was it. Can you read that? I'm sorry. Do you want me to zoom in more? What was it? Command, Option, equal? Yeah, I wish I would have brought my... It's horrible that you can't zoom in on... this code here. Then they briefly talk about the different types of strings and characters. They talk about how to put strings together, right? So if you want to have 2 words together, one is a string 1 and one is string 2, and you can put them together, as you can see right there. So you should try some of that. They show you how to put things together and adjust them there. And okay, let's move on. I'm sure you can figure out this string. It's pretty simple, but you should know how to, so practice that today in lab if you haven't done it yet. That would be lesson 2.1. Let's move on to the more important parts of the UI here, or this chapter, and that is how to organize your programming. The first concept they talk about here is called a function. You might have used functions already in some of the samples. It's basically a way of, again, organizing your code into groups, right? Again, the function here is how the function was implemented. It just worked. But if you want to write maintainable, reusable code, you need to be able to create your own functions, okay? So this is a way of making your own code for things. And they have some really nice examples in this as well. Just like in any type of programming, you need to define what you're making. In this case, a function starts out with the word func for function. Then you can give your function a name. Then you can put your parameters in round brackets or these, and then you can return a value if you need to. Okay, similar to declaration of a constant with let or variable, the function keyword tells the Swift compiler that you're declaring a function. Immediately following the func, you add the name of the function allowed by parentheses, which may or may not include a list of parameters within them. Finally, if the function has a return value, you write it with the arrow right here like this, followed by the type of data the function will return, such as an int, hopefully you know by now, is an integer. Then you have a string, which we just talked about, which would be, of course, words or person, etc. Let me move down here. Think about your daily routine. You probably identify plenty of repetitive tasks you perform each day, such as tying your shoes, making breakfast, driving to work or school. Some of these tasks require no additional input. You tie your shoes the same way you tie them. For functions without input, there would be no function parameters. Tie my shoe. However, each breakfast may have a list of ingredients, so they have a breakfast example. Let's move on there. So again, make breakfast with a round bracket, food, and then they have a list here, as you can see, eggs, comma, orange juice, okay? You know it's a list or an array because it has the round or square brackets, right? Didn't we do an array already in your lesson, right? So you can group things together. This would be the first item, I think. Didn't we do an item 1 last week where we removed item when we were debugging? You remember that? Yeah, okay, so just trying to reinforce what we did last week a little bit. Again, you can do a very simple one like this one, which says function display pi, and then they have of course the round brackets, and then you have the curly bracket with the print, and then this of course would print this out in the but you would need to, one of the things about a function is you can declare it, but unless you tell it to do something, you're not going to see anything, right? If you don't tell it to print, you know, it's not going to print anything. Let's look at the one down here. You'll notice that to specify a function with parameters, insert a name for the value and a colon and the value type, all inside the parentheses. For example, say you want to write a function called triple that takes an integer, triples the value, and then prints it. Okay, so here's a very simple example here. Again, they use the word func for function. They give it a name triple, and then in the round brackets they have value, which is with a colon, and then they tell it it's an integer so that you can use a mathematical equation on it, right? Okay, so if you want to use a mathematical equation on it, it's best to tell it that it's an integer. Then they make a constant by the name of result, and then they equal that to this value. This value right here is just an integer. Just an integer. This value, whatever number it is, times 3. So it says here, if you multiply value by 3, you'll get the results. So, you know, basically you would need to tell it what value is. You could give that something. So they're just telling you the results here. Let's move on to another example. If you come over here and then type in triple value equals 10, then you go, if they multiply 10 by 3, you'll get 30. We can type this into Playground if you want, just to see. We can start. You might want to follow along so that you can turn it in as well. So again, oof, I'm sorry, I have to have this zoom.
You have to provide the data type for both the function definition and the function call?
Well, when you want to, you need to give value a result, right? You need to put something into value in order to get it out. So you're giving it some information.
Value is kind of an ambiguous word.
Yeah, it's a made up.
It's
Yeah.
label for the value.
Yeah. It's a made up word there. In that example, it's a made up word. Okay, let me just let's just, it gave the value of 10, right? Triple is the name of the function, right?
Right.
Okay, then value is the word that they put in there.
It's the variable.
Yeah.
Parameter.
Yeah, and then they put 10 in there. So then after you run it in the console, it'll spit this out. So let's just try it so that we understand. I just need to find my Xcode. I'm just going to use playground, a blank playground. And we're going to call this one, what are we making? We're making functions. Functions. And I'm going to hit create. And then I can... Oh, I can't make this window smaller, can I? Wonderful. I need 2 monitors to be able to do this. So again, I'm just going to try this first example that they have right here. And so in order to tell it you want a function, you put F-U-C and C. And then they called it triple, round bracket, and then they put the word value in there. Then they put a colon, and then of course they called it an integer. Capital, remember the capitals are very important when you're working in there. Then in this case, you put a round curly bracket, and of course it automatically puts the end one in there. So they're going to make a constant called result. Let result equal value times 3. And then they want to print it out. So if you put print, round bracket, and then a quote, if you multiply and then of course you'll notice that the value is in round brackets here as well in this sample. And again, you'll see the word result. Okay, so at this point, you're not really getting anything because you never told the function to actually do anything, right? It's just code that's sitting there. You need to tell value to have some kind of value, and you do it later on after, we're setting it, that the purpose of the function is you're telling it, here's a chunk of code. Then later on in your, let's say it's a game, and you have a score, right? Hey, somebody won the game, boom, they're a winner. Then you would then add that to there. So you would use this is a way of organizing code, and then later on you'll give it values and it'll update. And so in this case, even outside the curly bracket, you can then, again, next page, the name of the function is triple, and then you round bracket, and then value, colon, and then we're going to give value a code, and we just called it 10. And now it should then give you the results down here. If you multiply 10 by 3, you'll get 30. Okay, so it's not inside the curly bracket. It's not inside there. You can call it in other places in your code. You can have it later on. It can be actually in a different Swift file. In fact, when we get to, we're going to be making multiple Swift files where you put a function in one, and then you can call it in the other one. They're inherent, and they talk to each other that way. Remember the controller. Okay, so in the future, you'll be making functions and classes and things in one Swift file, and they can be used in another Swift file. That's why it's not in the curly bracket. It could be used anywhere, even in a different Swift file. important thing is to look at how it's written and organized. There's going to be a couple different ways. You ready to move on? You get this idea for right now? Yep, okay. Let's move on. It's an important concept, though. You're going to be using functions a lot. It's used a lot. Again, you can actually have multiple values in your function. In this case, multiple arguments to a function. You need to separate each parameter with a comma. The following is an example of a function that takes two integer parameters, multiplies them together, and then prints the results. So if you look at this right now, you'll see this one says this function multiply first number with a colon, we make it an integer, second number colon, we make that an integer. Again, the same kind of thing with the results where they actually have first number times second number. The first example they just had 3, right? But yeah, you can have 2 numbers there. And then they print the results, and then of course down here you'll see it says multiply first number 10, second number 5, and of course you're going to get 50. I'm not going to type that in, but I think you get the concept there. Again, what they're trying to explain is you can have multiple right there with a comma, sorry, in between. And of course, they have an example of using a string down here. Function say hello, first name, instead of an integer is a string. Print hello, first name, and then of course you're going to give first name a value, right? You're going to put your name in there. So you would then use the same concept where you tell it to have a value. And if you look at the second page here, you'll see hello, first name, ID. And so the same concept with the integer, but that concept right now is using a string. And then you can actually have more. Imagine if you wanted your function to read a little more cleanly. And so they have multiple ways of doing it. And so again, you should go through the string chapter and see how to organize these all together. That's sort of what they're talking about here. They use an and here and a to here. So you can probably see that within the body of the function, to and and are very poor names. If you want the names of the constant within the function to differ from the argument labels, you can specify an external name before the local name. I guess that's what they're talking about here. I don't know, let's move on. So you should try some of these. Let's talk about the default parameter values. As part of the function definition, you can provide a default value for any parameters. This way you can call the function with or without the parameter. If the parameter is unspecified, the function will simply use a default value. You'll need to place all parameters with default values at the end of the list, and these parameters must all have argument labels. So in this case, they're going to give it a default value here of 0. So let's look at this one. Function display name or display, which I guess is names. You can see display here. And then they have team name with a colon, which is the name there of this option here. And then they have they make this one a string, which of course is the name right here, wombats. Then they have a comma because they're making another parameter here. And that one's going to be score. It's called score. And that's going to be a initialization, and they're going to give it a default value of 0 first. So again, you have the first one and then the second one, and then they put them together right here. Then later on, you will be able to update it, the score. So let's try this one. So, hold on, I'm going to move it this way, move it this way. So, again, they make a function display team name colon, and of course this is going to be a string because it's a word, and then they put a comma in there, and then the second is a score, and that's an integer with initial value of 0, and then they make curly bracket, and then they want you to print just so it comes out on the console, and then the quote with the / round bracket team name, and then score, oops, too many, and that's going to be quote. Oh yeah. I think I've.
The score is missing a close parenthesis.
Oh, it has it there.
Right there. Oh,
Where?
well, the quote and the close parenthesis are off.
Oh, there we go.
To have
Gotta have one there. There you go. Thank you. Okay, so but it's still giving me a problem.
Team name. It's not the same.
Team name, no capital N. Jeez, you guys are better eyes than me. Thank you. Okay, again, so you'll be able to make these functions anywhere in your code. In fact, when we get to making structs, the structures, you'll be putting functions in the struct, and so on. So if you look at this example, it's a pretty simple one here, but again, later on in your code, maybe even in a different Swift file, you want to update the score, okay? And so you can then put in the word team name. Of course, if we display it properly, and you'll notice that, of course, they want display first. And then we can then give it some values. So we need to give it some values. We're going to call it, well, they have wombats. I don't know. Do we have to be wombats?
That's it.
What's that?
From the Olympics, sorry.
Oh, I was going to put in the Giants. Wasn't it Fan Fest this weekend? Right? And then they changed the score. And then, of course, Giants is 100. Again, you can change that later on. Maybe they oh, the first line would be if you didn't give it any value. It would have been 0. Do you see that? So remember they gave it a default value, right? So maybe the default value, like at the beginning of a game, right, is going to be 0, right? Hey, you have won 0 games. So that's sort of what they're saying here with the default value. And again, what was I doing? Giants. And you'll notice it's 0. So the default value is 0 for the second parameter in that list. Because we did this here. Okay, let's move on. So then they go into more ways of putting numbers together, like in the multiply example. And in order to get the results, if you're using, let's say, numbers like they have right here, they'll be using the return value, return. The word results is made up here. As you can see, result is a constant, and it's made up here. So we could try this example if you would like as well. This is again to add two numbers and get the result. Of course, you know, we use the word print, so it would show up in the playground here. But really, you would use a return value because you're going to use that value somewhere else. So you use return basically in your code. You're not going to use print. Okay, you're going to be using return, so you can take that value and use it somewhere else. Does that make sense? That's basically what this page is telling you, is that you use the word return. So we could try it if you want. First number, and that's integer, and remember the comma in between. Second number, and then of course that's an integer as well, round bracket, and then you need to return the results. I think they said that with the dash and the chevron there, right? Do you remember that from the first page of this area? What I said, when you need to return the results right there, and the results you want to return is going to be an integer because we're adding two numbers together, and then you do your curly bracket. So again, we hit return, we get our second curly bracket. So again, let's look. Function is called multiply is the name of it. Where we got the first number is an integer, second number is an integer, and then we need to return a result as an integer. So remember in the first line they talked about using the dash, and of course this is a chevron, right? At least in web design we call it a chevron. I don't know, a little triangle, this one, chevron, right? I don't know. So then they have let result equal first number times second number, and then return result. And so that should fix any errors you had, because it was looking for the return value. So then you can go and then notice how they got rid of this. You don't need to write this line with the let. Do you notice it says return first number, second number? So they rewrote it like this. Do you see that? So let's try the result here. So the first thing I'm going to do is make a constant called my result. Then they'll use the name of the function and give some values to the first number and second number. I'm looking right here. So they have a let my result equal multiply and then first number and second number. And you'll notice when you're working, it starts coming up with information right there. See that? And you can double click on there and then quickly put in what you want. In their example, they have 10. And what was the second one? 2? No, 5. And then this is so hard to do with zoomed in like this. Now, of course, in order to see it, you would need to print, but my result now should be what? 50. don't know. Oh. I don't know. Let's try it. Where's the times at? Oh, above 8. Oops, I have too many now, don't I? Is that better? 10 times 5 is 50. So practice some of those. I don't know. It's a good idea, and let's move on. Oh, you want to do the test? Let's do the test. Okay, we're ready to go for the test. We feel our brain is working. Lots of coffee in it today. I hope so. Which of the following statements are true about the function below? Function greet is a name, and they told it it's a string, right? And then it says print hello name. Number 1, greet Jason with round brackets. I don't know. The first parameter requires an argument label. The function returns a string. Yes, I would say, right? Isn't this a string? The function has no return value. Yeah. Which one? Who says C? Who says B? A? A and B? C? D? Is that correct? C is not a string?
There's no return.
There's no return. A is wrong. Yeah, I didn't think a round bracket was good. But B is good. And C is wrong. Okay, let's move next one. Why does the following function not compile? Function increment. This dash right here, I believe, is to tell it that this value has data in it and will keep it from crashing. I believe that's what it was.
The underscore?
Yeah, the underscore at the beginning, I believe. Isn't that value?
You can optionally omit the value label when you call the function, I think.
Yeah, that's it. It allows you to keep your program from crashing if your value doesn't have anything in it, right?
No, if you don't write the word value colon.
Oh,
The
afterward.
value is like a user-defined label. It could say Jeff.
Oh,
So
okay.
underscore space Jeff colon int. Then when you call it, you don't have to say Jeff colon.
You could just use the word.
Just you just it's a shorthand. It's a way of saying you're allowed to shorthand the parameter label.
Without having to put everything in it, yes.
Yeah.
Very good, thank you. So what's wrong with this line they're saying? Why does the following function not compile?
The by amount is a phrase. It's not. It doesn't make any sense. It's not a variable label.
Yeah. There's no comma in between here. And I'm not sure you can have a space between this.
You can't. I spent a long time reading this yesterday. Sorry, Jeff.
That's okay, good, I'm glad.
So there's something called an external name and an internal name, and that was the part that they described. Remember when it said to and where the label?
Yeah, yeah,
back? The next page after that explained all this. So you had that was the funny thing. So we have
Two words in here is what you're saying.
So yeah, so what it says is the by is the parameter name when you're calling it, and the amount is the name of the variable inside the function.
Oh,
See how
okay.
they do value plus amount?
Uh-huh.
They're calling those internal names for the person who's writing the function or the method.
Mm-hmm.
And underscore and by are you can't actually call this using value and amount as your labels. You have to call it using nothing and by.
So
Increment 10 by.
colon 5.
Exactly.
So C.
Yeah.
No.
No.
B.
No, D. The functions are separated by commas.
Ah, that was right. That was
You
my
have to go
first
back
idea.
to that one critical page in the book.
Right
and
there.
Understand the labeling process.
And that was by the and option in
It
the
was
function.
Where it said and.
Yeah.
To an and. That page. It was the page after that.
Tells you how to put these together.
Yeah. And it kind of makes sense when you see it. Actually, it's not really complicated when you see that one single page paragraph.
Okay, let's check answer. Ooh, you guys got it. That's a good one. Okay, a function can be called using the code below. How was the function declared?
Eliminate A because it doesn't have a return, so we know A is not correct.
There's no comma in it either.
But it doesn't return that. There you go. Yes. They do. See the comma?
Is there a comma in it? I don't see any commas.
No
We
comma.
can't see it.
The comma's not visible back here, but is it C?
So what do you guys say? C?
It has to be something with an underscore because they don't provide a label for the first one.
C.
So it has to be C.
We can't see all the details back here.
I know it's hard. It's hard to see it even here. I don't know if I'm gonna.
B.
So which function returns two integers? Well, we got two integers here. This one has three integers there, and this one has a string and an integer, and this one has no. So you're saying B? All right. Boy, you guys are smart. Let's move on.
May I ask a question?
Uh-huh.
About the question number 3. Out of the options, there is not any comma between parameters. The number 3.
Yeah, I don't know. I don't see a comma there either. But that one looked the closest to me. Maybe because it's one value, they're using two words. Right? Like the one before.
Could be a typo.
No, it could be. Oh, shit.
Since that's not.
Could be like this. Maybe I'm assuming. Don't know. I didn't see a comma either.
Typing mistake.
Okay, let's move on to structures, which is probably the most important part. Functions are easy. You can see you can put them together to do things like keep scores and put words together and so on. But structures are a way to organize your content into building blocks. Swift comes with many useful types of representing data like numbers, text, collections, true, false values, but you get into building apps, you'll find you want to create your own data types with properties and functions of your own design. You create a custom data type by declaring a structure. A structure combines one or more variables into a single type. You can define functionality by adding type and instance methods to structures. In this lesson, you'll learn how to create structures, and you'll discover how structures form the building blocks of your code. So most of the things that we'll do will be either in structures or classes. Okay, so if you're... And they both do pretty much the same thing. It's just that classes, you can add subclasses to a class. Baby classes. So you may not have realized it, but you've been working with structures since the beginning of the course. Swift comes with predefined structures for representing common types of data. You can define your own structures when you want a type fits the specific needs of your program or app. In its simplest form, a structure is a name group of one or more properties that can make up a type. Properties represent the information about the instance of the structure. You define a structure using the struct keyword along with a unique name. You can then define properties as part of the struct by listing out the constant or variable declarations within the appropriate type annotation. The convention is to capitalize the name of types and use lowercase for the names of properties. Right? Consider a simple declaration of a person structure with a name property. So again, like in function, you name it, and then you say struct, then you give it a name, then you give it a colon, or I meant the curly bracket, and then again there's a variable. That variable is called name, and we're declaring it a string. Simple as that. Then later on, you can add to person, and so down here they're going to give it a constant. Let first person, so first person is a constant, is equal to the person, which is this struct up here, which is a string name, and we put the word name Jasmine in there, and then they print it out and it's Jasmine. But the first thing you'll notice right here is that they got first person with a point in between, and then the word name afterwards. Okay, so the name, this is the name Jasmine. As the name in the example implies, there may be more than one person that gets created throughout the lifetime of your program. The next instance you create could be called second person. If you could create a collection called people that holds multiple person objects. If you expect only create a single person, Swift allows you to create an instance of the person named person. So they do actually have a term called person if it's a single person. Let person equal person's name Zane. So let's move on to the example here. We can notice how they're including in the struct a function called say hello, and then print that. Okay, so you can combine functions inside of your struct. So let's try this example here. You can add functionality to a structure by adding a method. A method is a function that assigns to a specific type. In this example, our person's instance can now say hello. So let's try that one. So we can start with struct, person, round bracket, put a variable in there, and we're calling it name with a colon, and we're making it a string because it's a word. Then we're going to put a function in there, and then we're going to go say hello, and round bracket, and then we're going to say print hello there, my name is, and do your forward slash for the word name, and then whatever quote, and then round bracket. Uh-oh. Name. Oh, I spelled name wrong. Spell it right. Okay, so then you can go and I got 5 errors. There we go. Forgot to put a quote at the beginning. There we go. Okay, so in this example, I'm going to scroll down a little bit here. And let me get rid of some of these lines. Clean this up a little bit. There we go. So basically, we made a structure called person. You can have more than one person. You have a variable name because the name is of the person, right? And then they make a function that says hello to print out the actual words that you have there. And so later on, you can then go and give your name some value. So to give your name some value, they're using a constant here. Now you can call the instance method directly using the dot syntax. So in this case, you could say let person equal person, the round bracket, and then they use the word name, just like you would in the function in the previous chapter. And then name is a string, so we can put in a word in here. And what are we doing? Giants? Giants? And then we say person dot say hello, and then round bracket, and hopefully it'll print out something for you. Hello there, my name is Giants. That's I guess Giants is a name, right? I guess the name of a team. So in the following section, you learn more about instances. So again, there is a dot syntax here. You can now call the instance method directly using the dot syntax. So you'll notice person here, this person here, capital person here, person there, and then you have name, which is a string right here, and then we put it in quotes, and we put Giants. I put Giants in there. And then the person dot syntax say hello with the round brackets puts all this in there, because say hello is basically all of this, and then it spits out the output. So they got kind of, I think the shirt example is a little bit better, what they're going to talk about next in this example. You've just learned that structures define a new type. Okay, to use that type, you must create an instance of it, a process called initialization. After initializing, each instance inherits all the properties and features of the structure. In the following example, both my shirt and your shirt are shirts, objects with size and color properties, but each one is a separate shirt with a distinct value for each property, and therefore a separate instance of the shirt type, the size, and the color type define a group of available options called enumeration, which you'll learn about in the future. So if we go to the next page, they give you a shirt example that you can use the word shirt over and over again in multiple instances, right? Some people might have extra large shirt, some people might have a medium shirt. You'll notice the word shirt is here, so we're making a constant called my shirt, and it's using all the information that we put in this struct above here. So let's look at this struct above. So they make a structure called shirt, and in that shirt we can have certain values. I can have a variable called size, and I can have a variable called color. And so reusing this in multiple instances here, you'll notice down here you say let my shirt equal shirt, and then we can call these values that we have here, these variables right here, size extra large, color blue, and then again the same thing down here. You can use the same instance again. Let your shirt, which is different than my shirt, but it's still a shirt, right? You still have a shirt. And it has a size, because we told it, hey, you can have a size. And it does have a color. And so then you can make another one, and another one, and another one, and so on. Again, this is the basic structure here. And then you could make attributes of the shirt. And the reason why you're doing that is because it's going to get more complex. And in order to keep things organized, hence the word structure, right? A structure is a way to organize something, right? Structure of a building. foundation. So here's another example where they use the car. You'll notice that they have a struct called car. And then, of course, you can make a variable of a make, right? You could have Honda, Toyota, whatever. You could have a variable for a year, which is an integer, right? How many, what year was the car made? What color is the car? What is the top speed? Is an integer. Then you can have a function. In that function, the car can start engine. It could drive. It could park. And you could steer. And so you could have multiple functions inside of your struct. Each one of those functions can do a different thing. Park a car, drive the car, start the engine. Again, so these are all can then be called upon by different cars, right? But they all start engine, they all drive, and they all park. But you could. So down here again, just like the example above where you have two shirts, right? My shirt and your shirt. You can go down here and say first car, second car. And so then you have a car, which is the name of the struct right here. Then you have or the round bracket. And then, of course, it has a make, and you can give it a value. And then you can have a year, which is integer. And you can give it a color, which is blue. And same with the second car, and so on. And so they all can have a top speed, and so on. So what did the cars in the code do? If you imagine first car and second car facing out on the same driveway, only first car has moved after executing this code, while second car hasn't even started the engine. Notice, because it says first car has started their engine. And first car can drive. But we haven't defined that yet in the second car is what they're trying to say. So they introduce a new word here in this page as well, the init, I-N-I-T, which is an initializer. All Swift types come with an initializer, which is similar to a function that returns a new instance of the type. The default initializer is init with a round bracket. Instances created from the default initializer have a default value. The default string is the double quotes, the default initializer is 0, and the default Boolean logic is false. So just like in some values, it's best to, you're going to have to give it an initial value, and hence the word initializer right there. And that's where the round bracket comes in. But there's a shorthand version of the default initializer that's much more common. The following snippet is more concise, but works the same as the example above. Notice they don't even use the word initializer there. They just put the round quote in there. By default, a string is going to have nothing, but it's assuming that you put two quotes, right? Same with an initial value of the integer is going to be 0 right off the bat. And of course the Boolean, if you're doing a Boolean logic, yes or no, or false or true. So they talk about that on this page. And then they go over an odometer example. Of course, the odometer would read 0 at the beginning, right? And you'll notice they didn't have the initializer in this line, do they? They just have the word odometer with the round bracket right here, which by default is going to be 0. Note that the count is set to the default value of 0 when declaring the property. All new instances of odometer will be created with that default value. Of course, you might have more than one odometer. Each car has their own odometer. Sometimes you want to create a new instance with a non-default value. For example, you may need to initialize an odometer with mileage from an earlier trip or from a previous owner. When you define a new structure, Swift creates a specialized initializer called member-wise initializer that include all properties of the structure. The member-wise initializer allows you to set initial values for each property of the new instance. Count. And so on. So you should finish that. I'm going to jump. This is a very big chapter. I know some of you have already done this, right? At least try this one. It's important to understand that, especially with the double, which would be a decimal point. So make sure you go that. Let's jump to the classes real quick. There's a lot to this. There's a lot to this, a lot to that, a lot to that. Let's not even do the quiz. Let's jump to classes for a moment. So in lesson 2.4, they talk about classes and inheritance. We learned about structures as a way of compiling data and functionality into a type. Many programming languages also support another feature called classes that perform similar functionality. In special cases, classes can and should be used instead of structures. What is really the difference of a class and a structure? They're very similar, but the class is different than structures. When you use classes instead of structure, you'll also learn about. So basically the difference is that classes can be inherited and have child-like code to it. And as you can see, it's the exact same way that you would make a structure, but instead of using the word struct, you use the word class. It's the same kind of way that you would program it, but again, you define using class keywords. And then you can define a base class and so on. We can watch a video. Let me stop this for a moment.